So we might as well just advance to the homework slide in case people wanted to write that down. Were there questions from last week? Things you wanted to go over, talk about, before we just keep kind of jumping through it? It is the same homework as last week, yeah. There's no new homework. The exam is on Tuesday of next week. So this is the end of your homework. So the homework will be turned in on Tuesday. And yeah, that'll be the end of the homework.
This is the end?
This is the end for exam 1. Yeah.
This is the same one as last week.
It's the same one as last week. I notice people like to frantically scribble stuff down, so I figured I'd leave it up there just in case. Okay. Sig figs, or significant digits, sorry.
Canvas as well?
It's the same thing as the homework on Canvas, yeah. Okay, as you may have started to notice, the significant digits is something that's going to continue to recur for every single calculation. You have to apply your significant digit rules. So you need to be able to count sig figs so that when you're given a number to do some calculation with, you have to know how many sig figs are in it. You then go through and do a calculation, and you have to remember all of the rules for how you apply those sig figs to your answer. So every calculation done in this class is going to come back to these rules. All right? So if you have any trouble solving or remembering these rules, now is the time to get that fixed, because if you wait till after the exam, it's going to hurt you. You need to remember your prefixes and what those prefixes mean and being able to apply those. These are the ones that you should have memorized. In red, you will absolutely see. Right? Those are going to show up multiple times on the exam because I insist that you have those memorized. The other ones might show up a little kind of sparingly, kind of scattered around. So you still need to know those. You just won't be tested as heavily on those. Okay? Ultimately, they're just an application of your power of 10. Unfortunately, not everything is nice and simple in the metric system. We're also going to have to convert between English units. I will not require you to memorize your English conversions. Okay, so that's something that's you can consider as nice if you'd like. So if you're going to have to convert between English and metric, I will provide you a list of conversions at the beginning of the exam. I will try and put one of those together. And at very least post it this weekend so you know what information is given to you. Okay? The metric conversions on the previous slide, I'm not giving you any of those. All right? Unless I feel really particularly nice. These I will give you. So they will show up on the exam. You'll just have to reference them as needed for each individual problem. Okay? You might also get multiple different conversions or different ways that you could apply. If you guys remember when we solved this length of the American football field deal, there were 2 ways that you could approach and solve that problem. Both of them yielded the correct final answer. Okay, so in this case it was 11,000 centimeters, something like that. Okay, so if you apply your sig fig rules appropriately, you will get the exact same answer regardless of which way you go through and try and solve it. Does that make sense? Why would you pick one way over the other?
It's easier.
One way is easier than the other. That easier could very well be it's the only way you saw to go through and solve it, or it's shorter. Okay? It's entirely up to you to make that decision. Where we ended last week was looking at compound units. So now that we got an idea on how to convert simple units, we also have to realize there's other types of units. So the thing that, or the example we looked at is what is the speed on how you got to class. So any examples? What do you guys give me for a speed? Go ahead and work with it. So we got a miles per hour. It's a reasonable unit. Would you use miles per hour? Well, I guess you could use miles per hour for all of those, actually. What's your speed that you got here? Pick an average speed. 80 miles per hour average to get here, huh? Once moving on the freeway, okay. We can put in some qualifiers on that. So if we assume you're moving 80 miles an hour, okay, to get here, we can then use that unit or convert in a couple different cases. So there's a couple different ways we can look at this. You might have seen it written as it's written up there, which is the same as writing it 80 miles per hour with the slash. I would prefer a slightly different way to present that data. I would actually write it out as 80 miles, or mi, over 1 hour. Everything is 100% equivalent in that case. The only reason we're changing the notation around a little bit is that this now looks like a unit factor, whereas the other two formats don't look like a unit factor. Okay? The reason we want that unit factor is that's what's going to allow us, or what we can use in dimensional analysis, to convert our units across. Okay, so what do I mean by that? Let's say we wanted to convert that into kilometers per hour. Whoops, that's going to be a problem shortly here, and you'll see why. How do we convert that to kilometers per hour? How do we start our problem? Good. So if we want kilometers per hour, very first place I've been telling you to start is with the equal sign to our far right. You notice we've left a lot of space. If we don't need the space, oh well. Okay, equals what? Kilometers per hour. What information are we given to start with? We know we can move at 80 miles an hour. Compare our starting position to our end result, what we want. Okay, do you see anything that we don't need to worry about? Hours. Our hour unit is the same across the board. In both cases, it's in the denominator. We don't have to stress about hours. What about the mile unit? Is that what we wanted as our answer? No, we wanted kilometers. So what we need to do is come up with some way or some conversion, let's go orange, that can bring kilometers into the numerator. And what else needs to happen? We need miles canceled, so the miles needs to be in the denominator. Is there a direct relationship between kilometers and miles? Yeah? Anybody know what it is?
1.6.
Thank you. 1.6 kilometers is a mile?
Yeah.
Good. Why am I making funny faces? I didn't remember it. So 1.6 kilometers per hour. So that would be something that's given, or sorry, 1.6 kilometers is equal to 1 mile. So you'd see that given in your conversion sheet, written as probably 1.61, I now remember a little bit more about it, kilometers equals 1 mile. Come on. So you would have to use that straight line equation to generate your unit conversion. That's our 1.6 kilometers per 1 mile. What happens? Your miles, as far as units go, cancel, and we'd be left with kilometers. Okay? Why did I go through and add that extra 1? Why did I make it 1.61 and not 1.6? It's ultimately a sig fig issue. When we do our unit conversions, how many sig figs do we assume in our English to metric conversions? 3. Okay, so since I happen to know that it's 1, we have to make sure we've got that extra sig fig there. How about in the denominator? It's written as just 1. How many sig figs are in that number? Still 3. Why did we not write the 0.00? Thank you. We're lazy. Okay. So remember that in our standard English, so we'll say E to M conversions, we get 3 sig figs. Okay. And our answer.
All right. This is a little stupid. The 80 isn't that technically 1 sig fig?
That's where I was about to get to.
We're gonna.
So when we look at our answer, we can multiply 80 times 1.61. Anybody have a calculator handy that spits that out? What was it? So our calculator spits out that answer. if we're going to answer this question appropriately, we have to make sure that our sig figs are correct. What's the number that we actually report? We have to go back to our calculation and look at the sig figs in each of our multiplying or multiplication things. We've evaluated our conversion factor. Our English to metric has 3 sig figs. How many sig figs in our starting number? Why is it just 1 sig fig?
We don't count the 0.
Why does the 0 not count? No decimal point, so we can't count that. Which means when we go to our answer, as frustrating as this may be, how many sig figs need to show up in our answer? Only 1. So we take a look at our answer. The number, or the only number that's relevant as a significant digit, is that first one. See your hand, give me a sec. So when we go to report our answer is going to be 1, then we have to evaluate the next number after it. Is that number greater than, equal to 5, or less than? Less than, which means we do what? We don't have to do any real rounding. And we would get 100 kilometers per hour. Okay. Are those zeros significant? No. Why are they not significant? No decimal point. If we wanted to evaluate that and make that a little bit more clear that those zeros are just placeholders and not significant digits, we could also convert it into scientific notation. In that case, we provide our number, which is just the 1. Okay. We don't have any significant digits beyond that, so we don't need anything else, times 10 to the second. We've shifted 2 positions. To the left, it's positive 2. We could report it in scientific notation as well to help clarify those zeros. Kylie.
So you said with this metric conversion, you have to have 3 sig figs?
By definition, our metric conversions are established as 3 sig figs, yes.
Only the metric side goes?
Or sorry, not the metric, our English to metric.
Yeah.
English to metric conversions are 3 sig figs. How about metric to metric?
3.
It's fine if you remember 3, but it's actually better than that. It's infinite. It's an exact measurement because we're going by factors of 10.
So we wouldn't have to put 0.0 on the miles or on the hour outside during the conversion?
Here?
Yeah, because when you say English to metric, I think like both of them need to have it, but only the metric side needs to have 3 sig figs shown.
This conversion here to go between kilometers and miles, everything else irrelevant. 3 sig
Oh,
figs.
because that is the conversion itself.
Yeah.
Okay, got it.
Okay. Other questions with this? Yes.
So the final answer?
The final answer is either 100 kilometers per hour, no decimal point, or 1 times 10 to the second kilometers per hour. That's not 3 sig figs. It's only 1. Why do those zeros not count? No decimal point. And it's 1 because of our first calculation. Our first number has only 1 sig fig. No, I would definitely not supply both of those on the test. I would just pick one of those. Other numbers that might show up on the test. First answer, 128.8. Your calculator spit it out. Okay, if you aren't applying your rules, you'll write that number down. Next number. Huh? Good call. That's getting a bit tricky, but I might do that. 100 with a decimal point. What's the problem with that? 3 sig figs. Could also do 129. That's suspicious because we're starting to round. What's the problem? Too many sig figs. 130. Same issue. All of those come back to some version of rounding off of that, but rounding inappropriately. So when you go through and apply these, you must apply the sig fig rule first, identify what number has to show up, then apply your rounding into it. Okay? So that's where these get really tricky, is you have to make sure you're applying that rounding rule appropriately.
So let's just say
it was 158.8, you would have rounded the 1 to a 2, and it would have been 200 kilometers.
Yes.
Okay.
Everybody hear what she said? Okay. So let's, I'm not quite sure how I can do this because the math isn't going to work out. Let's erase a whole bunch of this. I shouldn't have erased that part of it. Let's say you go through and did your calculation, and this math does not work out, but let's say you've got 158.8. So let's pretend that was the answer. Or that's what your calculator said. What answer do you report? We go to our first sig fig, which is the 1. Okay, now we look at the next insignificant digit. What is it? 5. Is 5 greater than or equal to 5? What does that mean? We round up. So our answer becomes 200 kilometers per hour, or 2 times 10 to the second kilometers per hour. Okay? Kind of makes sense? Okay. It is a bit tricky. That's one of the reasons why we deal with these sig figs and try and go through it as slow as possible to start off with. Remember, the rest of the semester, you're going to keep coming back to these same rules, as frustrating as that may be. Okay? I don't like them either, so eventually, probably after the first test, you'll stop seeing questions where it gives you a whole litany of numbers that could all be potentially right, and you'll start seeing some variations in your answers. Okay? More kind of goat questions, or goat answer types. What else can we do with a compound unit? So all we've done now is converted it from one speed into another speed. What else could we do? Stick with our 80. Sorry, were there more questions on that actually? Good. What else could we do with this compound unit? We could use that to figure out a distance. Okay? How far did you travel? What information would you need to know to solve that? We would need a time in, let's be nice in this case, let's say 1 hour. Set it up the same way we've been doing all of our other conversions, all of our other calculations. So we start off with what? Equals. Equals what? What information should we know about what that equals? Okay. This question was written very poorly. This is what happens when I make things up really fast. We would expect some extra information here. The units of what our answer needs to be in. Okay. If the units aren't specified, what should you do? I would pick the easiest. Because at that point, I don't have to do as much work, and then if anybody said I was wrong, I go back and say, you didn't tell me what units to pick. I picked the easiest one. Stick to that. Works nicely. It's really fun if teachers don't write very clear questions and rub it back in their face. Okay? That said, I'm aware of that, so when I try and write questions, I'll try and make sure that's clear. So we want miles as our answer. What information do we know? We actually know quite a bit of information. What's that? We know the speed, so we could go through and start to incorporate our speed into this. Our speed is a fraction. Okay, what unit do we want to put on top? Why do we want to put 80 miles on top? What's our answer? Miles. Where's that miles unit? Numerator, denominator? In the numerator. So when we go through and put in our conversion factor, our unit factor of our speed, where should that miles unit show up? In the numerator. Otherwise, it's not matching what our answer needs to be. Are we given other information?
Yeah, you traveled an hour.
We've in an hour, so
Oh,
we've
sorry.
got a time. Where should we put that? Why do we want to multiply it? Our units disappear.
We can cancel.
Those units cancel. So what you might have remembered if you've taken a physics, rate times time gives you a distance. Okay, you don't need to know the equation, follow the units. The units will solve it for you. And the memorization technique was rate times time. Okay? So you can take advantage of the information stored in your units to solve the problem without knowing anything about what rate is or time or any of those other fancy words. Just let the units do the work for you. Okay? What else could we do? How about if we switch this around and said, you went, let's say you live kind of far away. Let's say you live 90 miles away. That's why you got to drive. That's why you got to drive 80 miles an hour. How long does it take you to travel 90 miles? Or how much time to travel that distance? And let's be extra mean here. Let's make it time in minutes. How do we set up our problem? Nobody? Our equals, and what do we know about our answer? It's in minutes. What other information do we know?
60 minutes in the
Okay, sorry, I know what you were going with that. We could go through with 60 minutes in 1 hour. Okay, so that's a conversion factor that we could slide into this. Okay. Where do we put our minutes in that? Why do the minutes need to go in the numerator? Because that's where the units are in our answer. So 60 minutes over 1 hour. Okay. Why did you pick hours and not say seconds? If we look at the other information supplied, what we're trying to do is convert that information across. So we need to get rid of that hour unit somehow. Okay? So we could work backwards from this. We need some way to convert hours into something else. Do we have a conversion for that? What do we have?
1 hour.
In 1 hour, we've gone 80 miles. Okay? What's happening with our units? Our hours cancel, which is nice. We'd end up with minutes, but get minutes per mile. Can we get rid of that miles somehow? How can we get rid of the miles? We need to multiply by something that has miles in the numerator. Do we have something like that? Yeah, we're given 90 miles traveled per 1. Okay, unitless. What's the result? You now have how long it took you to travel. Why did we do it in the way we did there? Because the first thing that was mentioned was 60 minutes per hour. Okay, that conversion factor. You didn't have to start with that. We could have started with the 90 miles. Okay, so let's work through that. Or should I work through that? You try and solve it from a different direction. Yes? No? Yes. So let's go ahead and erase that. I'll write it again. Don't worry. Okay? Minutes is what we're aiming for as our target. What information are we given? Okay, we've got a couple things that we could work with. We've got an 80 miles per hour, and we also have the 90 miles. Typically, you'll notice when we start these unit conversions that we almost always start with something in the numerator. Okay? So most people will start with 90 miles. So what we are trying to do is convert 90 miles into minutes. Okay? So our first attempt is to say multiply by something that relates miles and minutes. Do we have that conversion factor? Thank you. Do we have a direct relationship between those two? No. Okay, we've got miles per hour. Okay, since I've got that, instead of doing minutes, I'll go ahead and change my minutes to hour. Because I can now do that conversion. What's the relationship? I can do 80 miles in 1 hour. So this is cool. I've now adjusted. I've converted or gotten rid of my mile issue. Previously, that didn't match with our minutes. So we've condensed and simplified and got rid of the miles problem. What's the issue now? We get rid of the miles to only introduce a new issue. What's that new issue? Hours. Can we convert hours into minutes? So what we again do is set up our conversion and say, okay, I need to get rid of hours and I need minutes. What's the relationship between those? Okay. So that can load. Okay, let's see if we can get this back. Awesome. We got the slide back. Where were we? We had 90 miles. We knew we could travel 80 miles in 1 hour. We were aiming for minutes at the end. The conversion factor, we would hope that we can do hours into minutes. Do we have that ability? Yes. What is that conversion? 60 minutes, 1 hour. The net result, we'll get the exact same calculation. Okay? So it doesn't matter which way you attempt to solve the problem. If you want to start with a conversion factor or if you want to start the way your book is leading this out. Provide your answer, what information you know about your answer, and provide what you're started with. And start incorporating conversion factors after that. Okay? Entirely up to you in that order. If you want to slide that 90 miles calculation somewhere in between, for instance, if you started with 1 hour per 80 miles, this can be done, oops, sorry, that's a bit messy, 90 miles per 1. There's nothing underneath it. Remember, the 90 is in the numerator. And we could then multiply by 60 minutes. Our conversion is going to be exactly the same. The units still cancel. The order in which we put in that conversion or that information that we're starting with doesn't matter. It can happen at any given point. Okay? Yes. Lindsay.
Halfway answered, but you would do 80 times 90 times 60.
So now we should evaluate how we'd enter this into the calculator. Everything in the numerator, so this is how I would do it. I'd multiply everything in the numerator to get a number. So that's going to be 1 times 90, it's a 9, times 60, and I'd get a number. I'd then go through and multiply all the numbers in the denominator. That's 80 times 1 times 1. Once I have those two numbers, then I would divide top by bottom. Okay? Which would solve the problem when you initially said it. You said, I think, 80 times 90 divided by 60. If you do numerator first, then denominator, you don't have to worry about that divide until the very, very end, and you don't end up making a simple mistake in it. Okay? Why did we ignore the units at that point and just look at the numbers? You already did the unit conversion. All of that was already solved. So what you're doing is setting up your conversion factors to get you your units. Once you've got the units figured out, then you can go back through and mess with the math. Okay? And do the arithmetic of the problem. Okay? Questions on that?
When you round, what, do you just go to 70 or do you have one?
So we'd have to go back to the problem. You can tell how much I like sig figs because I didn't specify any units. I think we just had one in that one. So anybody actually calculate the number?
67.5.
So we get, as an answer, 67.5 out of the calculator minutes. We'd have to go back through and evaluate sig figs. And in this case, I'm pretty sure we started with 1 sig fig all the way through. Actually, yeah, with all of those. We've only got 1 sig fig, which means our answer becomes 1 sig fig, evaluate the next number. We get 70 minutes as our final answer. Okay? All of these steps get compounded in each calculation. Okay? Questions about that?
Wouldn't it be something like miles per minute or minutes per, what was that? I forgot the original question.
Look at the units in each calculation. Miles, cancel miles, hour, hour. Yes? Can I get you guys to be quiet? What was that?
Why 1 sig fig?
We'd have to go back through and evaluate each of our conversions. Minutes to hour, is it 60.012 minutes in an hour, or is it 60 minutes in 1 hour? How many sig figs in that number?
1.
It's exactly 60 minutes in 1 hour, which means infinite sig figs. Absolute worst, you can assume 3 sig figs. Okay? Here, okay, this isn't a generic conversion. This was something given to you in the problem. How many sig figs show up in this? So take a look at this number. How many sig figs in 80 miles? 1. How many sig figs in 1 hour? Okay, so we could look at it a couple ways. Since this was a measured thing given to you, you would probably assume that these are the numbers shown, okay, unless it's otherwise specified. Very least, this 80 is 1, which means your answer here is or your sig figs need to be what? 1. How about this one? This 1 is exactly 1 because we're dividing by exactly 1 in this case. Otherwise, we change that number. How about the 90? How many sig figs does the 90 have? 1, which means when we go through and do our math, this is all multiplication and division. Our rules for multiplication and division, we go by the least number of sig figs. 1 is the least number of sig figs, which means our answer must be carried to 1 sig fig.
Can we try one that is not 1 sig fig?
Yeah.
Example.
Yeah, give me a sec. I'll come up with one here.
So why is 60 infinite?
How many minutes are in an hour? 61?
60.
62? 59? No, it's 60. Every hour is 60 minutes. Exactly. That is our definition that we've put into that conversion. Okay? Every hour is made up by 60 minutes. Exactly. It's not 60.21, 60.0003. There are exactly 60 minutes in 1 hour. It's a count. Okay? Whereas in these other values, these are measurements. Okay? A measurement is going to have sig figs. An exact value has infinite sig figs. Jovan?
Oh, that was the same question.
Okay, so let's try see if we can come up with one with some more sig figs. Let's say we started with 62.3 miles in exactly 1 hour. That's a bit mean. Let's not do that. Let's just include that sig fig there. 0.00 hours. I want to know, I don't know, what do we want to know? We want to know the minutes per second. So what we're going to try and do is convert miles per hour into minutes. That doesn't work. Let's try miles per second. Okay, we'll do miles per second because that's a little bit easier and I want to move on a little bit more. Okay, so how would we start? Where do you start all conversions?
Convert hours to minutes.
With our answer, which needs to be in units of miles per second. What information are we given? We're given miles per hour. So we can include that on the front end. Do we do it hours per mile or miles per hour? How do we incorporate this into our question? Someone said it? Why miles per hour? We're finding the similarity. Our similarity is that our mile unit is in the numerator, which means the conversion, when we first bring it in, miles also needs to be in the numerator. So we get 62.3 miles per 1.00 hours. Do we have our correct units? It's always good to check just in case. No. What's wrong with it? We want it per second, not per hour. So we can go through and put in our conversion. Where do we want our hours? Why do we want it in the top? We're trying to cancel the hours unit. What do we want underneath? Let's go with ideal circumstances. We would assume seconds. Is there an easy direct conversion between hours and seconds? Don't do some math on me here. Okay, most people won't know that conversion. Okay, is there another conversion that you do know? What's that conversion? Hours to minute. How many hours to minutes are there? There's 1 hour, 60 minutes. I know where you're going with that number. We want to get rid of our minutes, and we want seconds to show up again in our denominator. What's the relationship between those? 1 minute is 60 seconds. We can go through and do our math. Anybody got a calculator? Punch it in. Give me a number.
It's a big decimal.
I know. Give me
How many?
5 sig figs.
0.017305.
Hi. Why did I pick 5 sig figs? We don't know anything about rounding yet, so I picked a number of sig figs that was well over what I already started with. Okay? So that we can at least look at it. You will have the calculator in front of you, so you'll have that information. Okay? Oh, where's the other 0? Oh. Okay. Still 5 sig figs. Why do those leading zeros don't count? Not count? There's no significant digit preceding them. So to decide what our final answer is, we now need to incorporate our sig fig rules. So we go back through each of our conversions and decide how many sig figs are there. Take a look at our, we'll go right to left. How many sig figs in this conversion? It's infinite. There are exactly 60 seconds in 1 minute. How many sig figs in our next conversion? Again, infinite. Next conversion? 3 sig figs. Which means our answer needs to have 3 sig figs. So we can go back to our answer, identify our 3 sig figs. Okay. Then we can evaluate our first insignificant digit. Is that what's that number's relationship to 5? Less than 5, which means we do what to our number? Stays the same, and our answer becomes 0.0173 miles per second. As a quick check, does that make sense? If we go 62 miles in an hour, if we now shrink our time scale down, should we travel further or less than a mile? Than that 62. Should be less. That rough approximation is a good skill to have, because what happens if you make the mistake and you multiply it by 60? Your number is going to get a lot larger. So you can then evaluate and say, does that make sense? Would it make sense if I traveled 10,000 miles in 1 second, if I could only go 62 miles in an hour? No. Okay? So try a simple test with it and evaluate, does that number actually make sense? If the number doesn't make sense, go back and reevaluate your calculation, okay, at least as far as homework goes. On a test, what should you do? Any ideas? Don't look for the answer because I guarantee the other one's going to be on there too. Okay? If you're guessing, then you just wasted all the time doing the work. Okay? What I would do is redo the calculation. If you get the exact same answer, then you probably did something wrong. Now I would guess. Okay? Because whatever you're doing is still giving you something that's nonsensical. Okay? On the other hand, if you get a new answer, now you can compare the work between the first attempt and the second attempt and see what's different between those calculations. It could have just been a calculator mistake. So you need to come up with some way to test your answers as you go to kind of evaluate. Yes?
So just for fun, the scientific notation would be 1.73 times 10 to the negative 2.
Just for fun, huh? Scientific notation, we'd start with 1.73 times 10. We want to see our, see our decimal shift. We go 1, 2 positions to the right, which means it is a negative 2. What was our units? Miles per second. Okay. Next question.
Is it not going to be multiple choice?
So as far as the test goes, what I think I'm going to do is set it up where it's all multiple choice, but the first portion of it will be show your work. Okay? The reason being, if you go through and set up and show your work, hopefully you'll get the answer right anyway, and it's not going to matter. If, however, you do a silly calculator mistake, you get the wrong answer every single time. But what if your work is right? That kind of sucks for you. You just lost all the points. So what I'll do is give you points based on your work. Okay? Which means in the show your work section, regardless of how confident you are with the calculation, you must show your work. Okay? Other questions? Okay. So we want to be a little bit careful about what our units mean. So there's a couple different things we could look at. 100 square feet is much different from 100 feet square. Okay? And it's all in how you end up applying what those individual things mean. 100 square feet is saying that we have 100 squares that are a foot on a side. 100 feet square says that we have 100 feet and 100 feet. Okay? If we go through and do those calculations, we get drastically different numbers between those two. Okay? So it's a pretty big difference. Be aware of what your units mean, where you're putting those individual terms. In most cases, that should be relatively obvious when you go through and do it. I don't think it's going to jump out and be that difficult to see when you go through and work the problem. Okay? How else are units important? This almost always happens with space for some reason. Apparently there's too much science going on there and too many people get confused between their English and metric units. What happened with NASA engineers? They confused the two. One person did a measurement in metric, the other person did it in English, and they thought their numbers matched. So they said, yep, it's good to go. And when they launched it, they got it up to Mars, and instead of hovering around the outside of Mars, it crashed. Okay? All because of a stupid, silly unit conversion that these people are getting paid hundreds of thousands of dollars to not make those mistakes. And then in the process, they then blow up this satellite, which then also cost millions of dollars. Okay? So these unit conversions are important. That said, they're really easy to make these mistakes. Okay? So watch out for that when you go through and solve. The idea is to realize that it's easy to make the mistakes, but it's something that you've got to track very, very carefully. Okay? So even a multi-thousand-dollar error can make these mistakes. Oh, so which brings us to the next point. What we'll go ahead and do is do the quiz. I'll give you about 10 minutes to go through and do this. I know that's 13 questions in 10 minutes. It's a bit rough, but hopefully it won't matter too much. I'll even let you leave your notes out if you want to use them. extras, just please pass them backwards.
Spelling doesn't matter, right?
Spelling doesn't matter as long as I can interpret what you're trying to spell. Did you not get paper? One more, please. Where's your extra paper?
Sorry. I didn't know how to play it.
I only gave you those two.
No, I like shoved it in there with that crap. Sorry.
Can we get an extra one? Forward now? Turn one more. I'll give you 10 minutes starting now. When are we done? 9:30? 40? 40. Yep. As long as I can interpret what you're writing, I'll be okay with it.